Alright, so section 6.4 is on taking different types of roots, and the most common type of root, or the one that's most familiar to most people, would obviously be taking the square root. But you can take any kind of roots. You can take cube roots, fourth roots, and so on. So we'll learn how to do that and how to simplify different types of expressions. And that's what nth roots means. N means whatever root you happen to be taking. So when you're taking a square root, n would be 2. When you're taking a cube root, n would be 3. Fourth roots would be n equals 4, and so on. Alright, so first thing is just to kind of clarify what a root is. You can see from this table right here, if you were to say, for example, 5 squared, and you were to say 25, the opposite of squaring something is taking the square root. So even though we don't write it, there's really a little 2 right there. It's saying, what did you square to get 25? And the answer would be 5. If then you did something like 5 cubed, 5 cubed means 5 times 5 times 5. 5 times 5 times 5 is 125. What's the opposite of cubing something? The opposite of cubing would be taking the cube root. And that's basically asking, what did I multiply by itself 3 times to get 125? And the answer would be 5. That's all that we mean by taking those different types of roots. Okay, here's just a little picture kind of showing what each of these means. So that the number underneath the radical sign, by the way, this root sign is called a radical. It comes from the Latin word for root, which is radice. Radice is Latin for root. So the number under the root sign is called the radicand. And then this number here, the root that you're actually taking, is called the index. So if you're taking the square root, the index is 2. If you're taking the cube root, the index is 3. Usually when we're taking roots, we prefer to use what is called the principal square root, and that means the positive square root. So the square root of 25, in earlier chapters we would always put plus or minus in front of it, but for this chapter, mostly you focus on the positive or principal square root. If you do want the negative square root, then you would actually put a negative sign in front of it to indicate that. And if you put plus or minus, that indicates both. You use both when you're solving equations. We're not going to be solving as many equations as section is more about just finding the root itself, which means generally use the positive square root or the principal root. Alright, so let's simplify this. Both of these involve taking square roots. This one, we want both of them. So what we would do here is really just take the square root of both of these. The square root of 16 would be 4, and the square root of y to the 4th, basically you have to ask yourself, what did I square to get y to the 4th? And the answer would be y to the 2nd power, because we're supposed to multiply those together. Okay, so you're not taking the square root of 4. When you're taking the square root, you're basically dividing this exponent by this number, which means dividing it by 2. So the final answer there would be 4y squared, plus or minus 4y squared. Okay, right here they obviously want the negative root, so we're going to take negative. And then same thing, if we kind of hash this out here, it says, what am I squaring? What am I squaring to end up with 8x to the, x squared minus 6 to the 8th power? So the question is, what exponent has to go right here so that when I square it, I end up with x to the 8th? And the answer would be 4, because 4 times 2 is 8. So how are we getting those exponents? We're basically just taking the power in there, taking the power 8, and we're dividing it by this number. We're dividing it by the root that we're taking. So 8 divided by 2 would be 4. We can't do anything more with, it's not like you can take the root of x squared or something, because that's not really x squared. That's x squared with that minus 6 attached to it. So you can never take, over here the reason we could do it is because this stuff here is being multiplied together. You cannot take roots individually. You can't split them apart when things are being subtracted like they are in problem B right there. Alright, a couple more. So these are not square roots now, at least not the left one. The right one still is. This one we're taking fifth roots. And to make this a little bit easier, first let's split this apart. So we have numbers that we're taking the fifth root of, then we'll take variables, the fifth root, and then finally we'll take the a variables and then the b's. It's actually easier to take the variable roots than it is the numbers. So the fifth root of a to the 20th, I just need to divide 20 by 5, and that would be a to the 4th. And just to confirm that, if you took a to the 4th and you raise it to the 5th power, you would actually get a to the 20. So that's how you can check. The fifth root of b to the 25th, well, 25 divided by 5 would be 5, so there's our b value. And then how do you deal with the fifth root of this number? What you want to do is basically look for fifth roots that happen to be, or sorry, powers of 5 that happen to be located in 243. So it's good to have a couple powers of 5 listed right here. So 1 to the 5th power would be 1 times 1 times 1 times 1, that's 1. 2 to the 5th power, it's not 10, it doesn't mean 2 times 5, it means 2 times 2 times 2 times 2 times 2, and that's 32. 3 to the 5th power is 3 times 3 times 3, and that actually equals exactly 243. So we didn't even really need to split this right here. We could have just directly taken the root. So the fifth root of 243 does equal 3, and that is as simple as we can make it. Over here we're taking the square root of, looks like the square root of a negative number, so that means we're going to get something imaginary. There's no real number that you can square, so let's split it up like this. Let's get the square root of negative 1 times the square root of 16 times the square root of x to the 4th times the square root of y to the 8th. This right here, we take half of that number to take the square root of it, that's y to the 4th. Half of this number is x squared. The square root of 16 is 4. And then another name for that is I. I is the same thing as the square root of negative 1. So the way that you could write this is usually the number goes in front, and then the I, and then those two variables. It's not wrong how we had it, although it would be kind of strange to just put the I in front, like I4. It's usually written as 4I instead. Alright, let's just do 2 more of these. So this is going to be plus or minus square root of 36 is 6, and then to get this one we take half of 10, we would get plus or minus 6x to the 5th. Let's just double check, that's right. And then this one right here, we'll have the negative, and then we want to take not the square root of that. Remember, when you're dealing with exponents, you take half of the exponent. That's going to be y plus 7, the whole thing, to the 8th power. And there it is. Okay. Here's another thing I want to mention, and this is kind of, it might not make sense the first time you see it, but hopefully with a little explanation it will make sense. If you are finding the even root of an even power, so for example, if you're finding the square root of 5 squared, let's say, which obviously is 25, that's the same thing as the square root of 25, and you get a result that's an odd power, so the square root of 25 is 5. Another way to think about it is taking half of that, we do 5 to the first. What you need to do, and what's the customary way to do, is to put an absolute value sign around that. Okay, and why do we do that? Because really there's 2 things that you could have squared to get 25. You could have squared 5, but you also could have squared a negative 5. And we said before that we usually want only to use the principal or the positive square root. So how can I avoid having negative square roots here? Well, if I could get 5 or negative 5, the way to guarantee only a positive answer is to put an absolute value around it, because the absolute value of 5 is positive 5, and the absolute value of negative 5 is also positive 5. Okay, so just to clarify, let's do just one more example here. Let's say we're taking the 4th root of, actually let's make it a square root again. Let's do 2 here. Let's do the square root of 6 to the 4th versus the square root of 6 to the 2nd. One of these is going to need an absolute value, the other one won't. Okay, so this right here will take half of that number, we get 6 squared. This right here will take half of that number, we get 6 to the 1st. Okay. So the question is, which one do I need an absolute value around? And the answer is only this one here. And the reason you need here is because we went from an even power to an odd power. Therefore you need an absolute value, because that could have been either plus or minus 6. Negative 6 squared is 36, and positive 6 squared is also 36. Okay, why do you not need a square root around this one? Because we're going from an even, sorry, not a square root, an absolute value. We're going from an even to an even, and here's why you don't need an absolute value. Well, what kind of number is it going to be if you raise something to an even power? If you put a positive in there and you square it, you're going to get a positive. If you put a negative in there and square it, you're still going to get a positive. So having an even power right here guarantees no matter what, it's going to be positive. That's why we don't need to put an absolute value. You could put an absolute value. It's not wrong if you do, but it's unnecessary. For this one, it's necessary because we're raising to an odd power, so we might get something which is negative. We must have the absolute value. For the even ones, you don't need it. It's guaranteed to be positive because you're raising to the 2nd or the 4th of some even power. Alright, so let's go through these and we'll see in each case whether we're going to need an absolute value. So we have a 4, we're taking the 4th root. So we just divide those numbers. 4 divided by the power will be y to the first. Do I need an absolute value? Yes, I do, because that's an odd number of power. So to guarantee that it's a positive number, I put an absolute value. Okay, here we're taking, that's an even power, and we're going to be taking the 6th root, which means dividing by 6. Actually, let's split this up, because we have a 64 here, and then we also have, that's the 6th root, we also have the 6th root of this thing right here. Okay, so what is this going to be? Well, if we take 18 and we divide it by 6, we would get this right here, x squared minus 3 to the 3rd power. We need an absolute value around that, because that is an odd, that's an odd power. The 6th root of 64, it's actually a perfect 6th root, but it would be good to write these out. 2 to the 6th power actually is 64 exactly. Okay, so we're going to put that to the 2. And then let's think about it. This, really what we're doing right here is we're taking the 6th root of 2 to the 6th. That's an even power. When we divide it by 6, we get an odd power. And so that means we went from even power to odd power, we need an absolute value around that. Okay. Sometimes what people do in that case is they will put both of those inside the absolute value, but it doesn't, in this case, it's not really that important. You can just leave them separate. Okay, let's do a couple more here. So this one right here, the square root of 36, well that's, let me just write this like this, that's the same as 6 squared, and y to the 6 is here. When we take the square root of that, 6 divided by, there's like an invisible 2 there, we get y to the 3rd. That's an odd power. We went from even to odd, so we need an absolute value. Same thing here, if we take the square root of that, we get 6 to the 1st. That's an odd power, so we need an absolute value. And you can write that a little bit more compactly as both the 6 and the y cubed in the absolute value. Okay, then we have this one right here, so we're going to take 12 divided by 4. Actually, let's once again split this up. For the 4th root of 16, and then the 4th root of this thing right here. Okay, the 4th root of 16 is 2, because 16 is 2 to the 4th power. We're going from an even to an odd, and so 2 to the 1st, that means absolute value, because that's an odd power. And then we take the 12 and divide it by 3, we get x minus 3 to the 3rd. Again, we went from an even number 12 to an odd number 3, so we'll put an absolute value around it. Okay. Here's the last problem. This is just a kind of a real-world application type problem. Square roots are used obviously in a lot of everyday scenarios. We'll probably see some more later in this chapter, but they have this equation here. Just move this a little bit. It says, it's not actually working well. Here we go. It says, according to, this is in the bottom left corner, according to an injury prevention study, collisions between bikes and automobiles increased as the number of bikes per intersection increased. And they found this equation right here. C equals, and C stands for the number of collisions, the 5th root of b squared, and b is the number of bike riders per intersection. Okay, the first question says, estimate the number of collisions at an intersection that has 1,000 bicycle riders. And that means b is equal to 1,000. So all we're being asked to do here is just plug in the number 1,000 for b. Okay, we want to use a calculator for that, which we'll do. So I'm going to show you also where to find the 5th root in the calculator, because it's not obvious where to find it. So what you do is go to math, and then, actually let's go back to the main page. We want to find the 5th root, so we're going to put a 5 right there. Then go to math, and then this button right here, the little x right there, the x stands for what root you want to find. We want to find the 5th root, so we had to put that 5 there before we clicked on that. And we're trying to find the 5th root of what? 1,000 squared is 1,000,000. So 1 with 6 zeros. And what does that equal? 15.85. So the number of collisions is about 15.8, so somewhere between, they say estimate, so about 16. We'll just use the decimal answer, 15.85. Second question here, the last question says the total number of collisions reported in 1 week is 21, so that means now C is 21. C stands for the number of collisions. If this is 21, estimate the number of bike riders. So we're being asked to solve for B. How do we do that? We need to cancel out that 5th power, and the opposite of taking the 5th root is raising to the 5th power. So I meant to say we need to cancel out taking the 5th power. So those cancel. Whatever we do to one side, we have to do the same to the other. So we're going to get b squared equals 21 to the 5th power. How do we solve for b? We square root it. So we're going to square root 21 to the 5th power. Okay, so let's see what that ends up being. So the square root, second square root of 21 raised to the 5th power, and we end up with 2020 bike riders, basically. That's how many bike riders you would need to have that number of collisions. Alright, so that is the end of section 6.4 on simplifying roots. We talked about how to simplify 4th roots, 5th roots, and so on. And then you need the absolute value when you're going from an even number power to an odd number power. So hopefully that helps clarify some things.